Welcome to the course module of Communication Engineering. And in this video, we are going to solve another problem which was asked in the GATE 2020 examination. So the topic of this problem is related to the double sideband suppressed carrier modulation scheme. So please go through this statement which is mentioned here, and we'll try to see how to solve this problem. Okay. So for the modulated signal, which is defined as xt equals to mt cos 2 pi fct, and the massive signal mt is defined as 4 cos 1000 pi t, and the carrier frequency fc is 1 megahertz. The signal xt is passed through a demodulator as shown in the figure below. The output yt of the demodulator is okay. So basically we have to find out this output yt of this particular demodulator. Okay, so here we can see this is the scheme. Okay, this is the scheme shown here. Okay, and xt is actually being defined by this particular expression, right? So it is mt multiplied with the cos 2 pi fct. So this is nothing but your DSB-SC signal. Okay, so here we can start solving this problem based on the given statement. So here are the options mentioned, right? So now we can start with, we can see this xt is being defined as mt cos 2 pi fct. So if we substitute the value of mt, which is given over here, okay, so this you can see this mt is actually given as 4 cos 1000 pi t. So this can also be written as 2 pi fmt. Okay, so where fm will be equals to 500 hertz, and here this carrier fc is given as 1 megahertz. It means it is 10 to the power 6 hertz, right? So you can substitute this value here. So here we can write xt equals to 4 cos 2 pi into 500 t cos 2 pi 10 to the power 60, right? So if we see this expression, we can write in this particular notation. Okay, so I will write this value as fmt, 2 pi fmt, and cos 2 pi fct. So I will be solving this problem in the form of fm and fc only. And at the end of the solution, we will substitute for fc and fm. Okay. So obviously here this fm value is equals to 500 hertz and fc is equals to 10 to the power 6 hertz, right? So now if we see this particular expression, we can expand this equation by using the formula 2 cos A cos B formula. So we know that the 2 cos A cos B formula can be written as cos A plus B plus cos A minus B. So if we follow that particular expression, this you can write as 2 cos, there is a factor of 4, so it can be written as 2 multiplied with 2. Okay, so that 2 cos A cos B formula you can apply, and this another factor 2 will come over there, right? So here we can write this as 2 cos 2 pi fc plus fmt, and here it is 2 cos fc minus fmt. So this will be the equation, right, after expanding this particular product. So here we can see this is the xt term, right? This is the xt term which is coming over here, right? So now because this is our xt term, this xt term has to be multiplied with this particular given carrier. So here is the given carrier because it is demodulating the signal. So here this carrier has to be multiplied with this xt term, right? So here I have defined the output of this particular product modulator here. So after this multiplication, this signal I have defined as Vt. So this Vt is nothing but xt multiplied with this particular carrier, right? So here that is the equation. So here we have to just substitute for this xt value. So xt is 2 cos 2 pi fc plus fmt, and 2 cos 2 pi fc minus fmt, right? And this has to be multiplied with the carrier 2 cos 2 pi fc plus 40t. So now if you solve this problem, okay, we multiply this expression. Okay, so here again we can use the formula for your 2 cos A cos B formula again, okay, for this two term, right? Then again we can apply the 2 cos A cos B cos B formula for this two term. Okay, so there are two such product terms, right? So if you apply that, you will be able to show that this expression will become this. Okay, cos 2 pi 2fc plus fm plus 40t, cos 2 pi fm minus 40t, cos 2 pi 2fc minus fm plus 40t and cos 2 pi fm plus 40t. So here we can easily show that this particular signal Vt, okay, this PT is actually passing through the ideal low pass filter. Okay, so we have to pass this particular signal Vt through this low pass filter. And because the cutoff frequency of this low pass filter is 510 Hertz. So we have to remember that after passing through this particular low pass filter, all the signals which are having frequency component greater than 510 Hertz will be rejected by the filter. Okay, so all those signals will be rejected, right? So we have to find out what are those components which are having frequency component greater than 510 Hertz. So here we can see it is 2fc plus fm plus 40. Okay, so because fc is equals to 10 to the power 6 1 megahertz, so obviously this frequency is much larger than the 510 Hertz, right? And therefore this first term will be going to be rejected by the filter, right? Again, if you see this particular component, right, we can see this particular component. Again, it is 2fc minus fm plus 40, right? So again, it is somewhere around 2fc, okay, because fm is much smaller than the fc. So again, this frequency component is somewhere around 10 to the power 6, right? And again, it is a very high frequency component and it will be rejected by the filter, this low pass filter, okay? Now we are left with this two term, for this term and this term. Okay, so now you can see if you substitute for FM, right? So FM is 500 Hertz. So 500 plus 40, it will become 540 Hertz. Okay, so because this 540 Hertz is greater than the 510 Hertz, and therefore this component is also going to be rejected, right? Because it is not comes under the passband of your low pass filter. So this component will also be rejected, right? Now here we can see this particular component. Okay, it is FM minus 40t. So FM minus 40 means 500 minus 40. So it will be giving you 460 Hertz. So because this is the only component whose frequency within the passband of your low pass filter, therefore only this component will be passed through the filter, and rest of all the terms will be rejected by the filter. Okay, so we can see that the output of this low pass filter is cos 2 pi fm minus 40t. So here you can substitute for fm, so fm will be 500, and here you can substitute, you can solve this expression, it will be cos 2 pi 460t. So if you multiply this two term, you are going to get this as cos 920 pi t. So here you can see this option, you can get this option in the option B. Okay, so this option is already mentioned here. Okay, so the right answer for this question is option B. So if you have any doubt, let me know with your comments. Okay, so thank you for watching this video.